October 23, 1944. Rechlin Experimental Airfield, Germany. The sound alone stopped conversations across the entire flight line. Oberst Werner Streib watched through his office window as the massive fighter taxied past German mechanics who had paused mid-task, transfixed by the deep, thunderous rumble of the Pratt and Whitney R-2800 double Wasp engine. The aircraft, bearing fresh German markings, coded T9 plus FK in yellow paint, represented something that contradicted 3 years of Luftwaffe assumptions about American fighter design philosophy. Americans cannot possibly mass-produce fighters this heavy, this complex, this powerful, while maintaining any semblance of combat effectiveness. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Through the plexiglass canopy of the captured Republic P-47D Thunderbolt, Hauptmann Heinrich Voidich prepared for a test flight that would fundamentally challenge everything German fighter doctrine taught about the relationship between weight, performance, and tactical capability. The Thunderbolt weighed 7 tons empty, nearly double the weight of a Messerschmitt Bf 109, and exceeded even the robust Focke-Wulf FW190 by more than 2,000 pounds. German engineering philosophy held that such weight represented fatal compromise, sacrificing the agility and climb rate essential for fighter combat in pursuit of misguided American obsession with pilot comfort and survivability. What Voidich and his fellow test pilots at Rechlin would discover during the months ahead would prove more revelatory than any intelligence briefing. The firepower, the structural strength, and above all the diving performance concentrated in this single aircraft when multiplied across hundreds of fighters escorting American bomber formations created a level of air superiority that German fighter pilots increasingly could not counter. The massive Thunderbolt represented American engineering philosophy made manifest in aluminum and steel, prioritizing pilot survival and tactical flexibility over the pure performance metrics that dominated German design thinking. The transformation from enemy weapon to intelligence revelation had begun 2 months earlier on August 17, 1944. Second, Lieutenant William Roach piloted P-47D serial number 4-2-2, 6745, during an escort mission protecting B-17 flying fortresses, attacking ball-bearing factories in Schweinfurt, deep in southern Germany. His aircraft, part of the 356th Fighter Group based at RAF Martlesham Heath in Suffolk, England, carried the nickname Little Demon, painted on its engine cowling by American ground crew. The 356th Fighter Group, known as the Martlesham Marauders, had been operational since October 1943 and had accumulated nearly a year of intense combat experience escorting heavy bombers throughout occupied Europe and into Germany itself. On this August afternoon, the group furnished 48 P-47Ds for a maximum effort mission targeting industrial facilities, whose destruction American planners believed would significantly impact German military production, particularly the manufacture of aircraft engines and mechanical components essential for tanks and other armoured vehicles. The mission proceeded according to plan through the initial stages as the formation crossed into German airspace. But Luftwaffe fighters from multiple units intercepted the American formation with aggressive determination over central Germany. Messerschmitt Bf 109 Gs and Focke-Wulf FW190 as attacked the escort fighters with coordinated tactics, attempting to draw American fighters away from the bombers they protected. The German pilots understood that breaking up escort formations offered their best chance of reaching the vulnerable bomber formations. During the swirling engagement that followed, Roach's Thunderbolt sustained hits from 20mm cannon fire that damaged the engine cowling and severed critical control cables. White coolant vapor began streaming from the engine as internal temperatures climbed toward dangerous levels. The massive radial engine, normally unflappable in its reliability, began running rough as damaged cylinders misfired and lost compression. Roach faced the calculation every fighter pilot dreaded as his aircraft's condition deteriorated rapidly while still deep in hostile territory. Attempting to reach England across hundreds of miles of German-controlled territory with a dying engine meant certain capture when the engine finally quit. Bailing out over Germany guaranteed prisoner of war status at best, with the possibility of angry civilians or vengeful German soldiers making survival uncertain. The only option that offered any control over his fate involved an immediate emergency landing while the engine still produced partial power. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Scanning the landscape below through breaks in his damaged canopy, Roach spotted what appeared to be a suitable field near Eisenach, a historic town in central Germany approximately 200 miles northeast of Frankfurt. With considerable skill under desperate circumstances, he brought the 7-ton fighter down for a wheels-up landing in a large meadow. The Thunderbolt slid across grass and dirt, its distinctive shin air intake gouging a long furrow before the aircraft ground to rest in a cloud of dust and torn vegetation. Roach emerged from the cockpit with hands raised, expecting German soldiers to arrive shortly, and his war to end in a prison camp. What he could not anticipate was how valuable his intact aircraft would become to Luftwaffe technical intelligence services desperate to understand the capabilities of American fighters that were systematically achieving air superiority over the Reich. Within hours, Luftwaffe recovery specialists and Wehrmacht soldiers had secured the crash site with orders to prevent any damage to the captured fighter. Engineers photographed every system, every panel, every visible component before the aircraft could be contaminated by souvenir hunters or deliberate sabotage. The Thunderbolt represented exactly the kind of intelligence windfall that German technical services had been seeking for months, as American escort fighters demonstrated increasingly worrying capabilities in combat. Most downed Allied aircraft arrived at German evaluation facilities as scattered wreckage, their secrets fragmented across impact craters or consumed by post-crash fires that destroyed critical components and systems. But Little Demon sat nearly complete in a Thuringian meadow, a comprehensive example of American fighter technology available for detailed exploitation and analysis. German recovery teams immediately recognized the extraordinary value of the prize before them. This was not merely another crashed fighter to be stripped for scrap aluminum and salvageable parts. This represented the first intact P-47D Thunderbolt to fall into Luftwaffe hands in repairable condition, offering unprecedented opportunity to study American fighter design philosophy, construction methods, armament systems, and most critically the performance characteristics that were allowing American fighters to dominate German interceptors with increasing frequency. German technicians worked with practiced efficiency to transport the damaged but fundamentally sound fighter to a temporary facility at Erfurt Airfield, where initial repairs could be completed. The transportation process required careful planning to prevent additional damage to components that might prove essential for understanding the aircraft's capabilities. Specialized heavy equipment moved the 7-ton fighter onto transport vehicles designed for recovering crashed aircraft, regardless of terrain conditions. 5 days after capture, on August 22, 1944, German mechanics completed sufficient repairs to make the aircraft flyable for ferry flights to evaluation facilities. The massive Pratt & Whitney R2-800 engine required extensive work after combat damage and crash impact had compromised multiple systems. German technicians, working without factory manuals or original spare parts, demonstrated remarkable ingenuity in fabricating replacement components and repairing damaged systems using materials and parts cannibalized from other crashed P-47Ds recovered across occupied Europe. Fuel tanks received careful inspection and testing to ensure no leaks existed that might cause catastrophic fire during flight operations. The hydraulic system underwent complete examination as German engineers understood that control surface operation depended entirely on hydraulic pressure in this sophisticated American design. Control cables were repaired or replaced where combat damage had severed or frayed them. The landing gear, retracted during the belly landing, required careful examination to ensure it would extend and lock properly for future operations. German national insignia replaced American markings throughout the airframe. Large black crosses adorned the wings and fuselage sides. A swastika marked the vertical stabilizer. The entire aircraft received a fresh coat of RLM-02 grey-green camouflage paint, typical of Luftwaffe fighters, though the distinctive shape remained unmistakably American. The code T9 plus FK was applied in large yellow letters to both sides of the rear fuselage for easy identification by German pilots and anti-aircraft crews. 2 Messerschmitt Bf-109 heavy fighters took position as escorts, and a carefully selected German test pilot climbed into the unfamiliar cockpit for the ferry flight to Rechlin, the Luftwaffe's premier aircraft testing and evaluation center, located approximately 120 kilometers north of Berlin, near Lake Müritz. The flight plan was distributed to every Luftwaffe fighter base and flak battery along the planned route, with explicit instructions not to engage the captured Thunderbolt, despite its unmistakable Allied design. The precautions proved essential. Despite clear German markings and pre-coordinated flight plans, some Luftwaffe anti-aircraft positions fired on the captured fighter as it passed overhead, unable to overcome trained instincts to shoot at any aircraft with the characteristic wide, bulky profile of an American fighter. Recognition signals were hastily transmitted, and the firing ceased before serious damage occurred, but the incident demonstrated both German eagerness to destroy American fighters on sight and the coordination challenges facing a military organization increasingly strained by fighting defensive battles on multiple fronts. Simultaneously, when the Thunderbolt touched down at Rechlin after its circuitous flight from Thuringia, it entered an institution dedicated entirely to understanding enemy aviation technology and developing countermeasures. Rechlin served as the central testing facility for all Luftwaffe aircraft evaluation programs, functioning as Germany's equivalent to Wright Field in Ohio or the Royal Aircraft Establishment at Farnborough in Britain. Every captured Allied aircraft that could be restored to flying condition eventually arrived at this secretive installation. Here, German engineers systematically dissected foreign technology, searching for exploitable weaknesses and studying innovations that might be copied or countered through German design modifications. The facility employed hundreds of technicians, engineers, test pilots, and support personnel united by the single mission of understanding how enemy aircraft functioned and identifying methods to defeat them in combat operations. For nearly 6 weeks following its arrival in late August 1944, the captured Thunderbolt remained grounded, while specialized teams conducted exhaustive examination of every system and component. Engineers removed access panels throughout the airframe to study structural design, marveling at the extraordinarily robust construction that gave the P-47D its reputation for surviving battle damage that would destroy lighter fighters. They measured skin thickness, finding aluminum panels significantly heavier gauge than German practice. They analyzed structural members, discovering frame spacing and reinforcement far exceeding what German designers considered necessary. Every system received meticulous documentation that would be compiled into comprehensive technical reports. The electrical system, with its sophisticated wiring harness and circuit breaker protection, revealed American approaches to aircraft systems that prioritized reliability and maintainability over weight savings. The hydraulic system demonstrated complex valve arrangements and pressure regulation systems that operated control surfaces far larger and heavier than anything in German fighters. The oxygen distribution system showed American understanding of high-altitude operations where pilots might spend hours above 25,000 feet in temperatures far below zero. The radio equipment, manufactured by Radio Corporation of America, provided clear communication across remarkable distances despite engine noise and electrical interference. The fuel system, with its multiple tanks and complex transfer arrangements, allowed pilots to manage fuel distribution for optimal center of gravity throughout the mission profile. The supercharger installation particularly fascinated German engineers who understood forced induction systems intimately. The massive General electric turbo supercharger, mounted in the rear fuselage, represented a fundamentally different approach to high-altitude performance compared to German mechanically driven superchargers. This system used hot exhaust gases to spin a turbine that drove a centrifugal compressor, forcing compressed air into the engine at high altitude, where thin atmosphere normally starved engines of oxygen needed for combustion. The implications were immediately apparent to German engineers who understood engine performance. While German inline engines like the Daimler-Benz DB605 used mechanically driven superchargers that consumed engine power to compress intake air, the turbo supercharger recovered otherwise wasted exhaust energy. This meant the P-47D's engine could maintain sea-level power output to altitudes exceeding 30,000 feet, where German fighters with mechanically driven single-stage superchargers experienced significant power loss as air density decreased. Luftwaffe aeronautical engineers found themselves grudgingly impressed by aspects of American manufacturing philosophy revealed throughout the Thunderbolt's construction. The fighter demonstrated mass production techniques on a scale that made even Germany's most efficient aircraft factories appear artisanal by comparison. Standardized components meant parts manufactured at Republic's Farmingdale factory on Long Island would be interchangeable with identical components from the Evansville, Indiana facility without custom fitting or modification. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Simplified assembly sequences reduced the skilled labor requirements for workers, allowing semi-skilled employees to build complex fighters using jigs, fixtures, and carefully documented procedures. Everything about the aircraft's design indicated an industrial philosophy fundamentally different from German practice, where even late in the war, skilled craftsmen hand-fitted components through labor-intensive processes that limited production rates regardless of available factory capacity. Where German aircraft required experienced workers to achieve proper fit and finish through individual adjustment of each component, American fighters used standardized modules that less experienced workers could install rapidly using documented procedures and specialized tooling. The strategic implications were sobering for German planners who understood industrial mathematics. If one captured fighter showed this level of manufacturing sophistication, indicating an industrial system optimized for volume production at consistent quality levels, how many could American factories produce monthly? The numbers, when German intelligence analysts performed calculations based on observed manufacturing approaches and known American industrial capacity, suggested production rates that seemed almost impossible, yet would prove conservative. Republic Aviation alone would manufacture more than 15,000 P-47D Thunderbolts between 1941 and 1945, with peak monthly production exceeding 600 aircraft during 1944. Total American fighter production across all types would exceed 99,000 aircraft during the war, a figure that dwarfed German fighter production by factors that made strategic victory through attrition mathematically impossible for Germany. On October 7, 1944, the captured Thunderbolt finally took to German skies for its first evaluation flight under Luftwaffe control. Hauptmann Heinrich Voidisch, an experienced test pilot selected for his engineering background and mature judgment, conducted the maiden flight from Rechlin. The initial impression, even before advancing the throttle for takeoff, centered on the aircraft's sheer size and mass compared to familiar German fighters. The cockpit sat high, above the ground, providing excellent visibility over the massive engine cowling during taxi operations. American pilots had consistently praised the P-47D's ground handling in reports that German intelligence had obtained through prisoner interrogations and captured documents, and German test pilots quickly confirmed these assessments. The fighter taxied smoothly despite its weight, the wide-track landing gear providing stable ground handling even in crosswinds. Voidisch ran through the unfamiliar starting procedures, which German technicians had documented through careful observation and experimentation. The massive 18-cylinder radial engine coughed to life with a distinctive deep rumble entirely different from the high-pitched whine of German inline engines. The sound alone communicated power and reliability in ways that transcended technical specifications. At full throttle, the R2-800 produced 2,000 horsepower, exceeding the output of any operational German fighter engine by substantial margins. The takeoff roll felt surprisingly short considering the aircraft's 7-ton empty weight, testament to the engine's enormous power and the wing's efficiency at generating lift. The Thunderbolt lifted off smoothly and climbed away from Rechlin at a rate that surprised Voidish based on his expectations for such a heavy aircraft. The rate of climb, while not matching the best German fighters at low altitude, remained entirely adequate for operational requirements and actually exceeded German fighter performance above 20,000 feet, where the turbo-supercharger maintained full engine power. Once established in level flight, Voidish began systematic exploration of the flight envelope, testing control responses and handling characteristics across different speeds and configurations. The controls felt heavier than German fighters at all speeds, requiring more physical force to achieve equivalent control deflections. But the control forces were beautifully harmonized, with aileron, elevator and rudder forces, increasing proportionally with airspeed in ways that provided excellent pilot feedback without becoming exhaustingly heavy. The Thunderbolt responded to control inputs with solid, predictable behavior free of any unpleasant surprises or dangerous characteristics. Roll rate, while not matching the exceptional performance of the Focke-Wulf FW-190, remained entirely adequate for combat maneuvering. The aircraft could be thrown into various maneuvers without displaying tendency toward departure from controlled flight, spin entry, or other dangerous characteristics that could prove fatal in combat situations where pilots might exceed normal flight envelope limits during desperate defensive maneuvering. German test pilots at Rechlin conducted numerous flights throughout October and November 1944, systematically exploring every aspect of the aircraft's performance and handling characteristics through standardized test protocols. High-altitude performance evaluation demonstrated the Thunderbolt's most significant advantage over contemporary German fighters. The massive fighter could operate comfortably above 30,000 feet, where the turbo-supercharger continued delivering full-rated power, while German fighters with single-stage mechanically driven superchargers experienced severe power loss. At 30,000 feet, the R2-800 still produced nearly full sea-level power, maintaining speeds and climb rates that German fighters simply could not match at equivalent altitudes. A Messerschmitt Bf-109G, the most numerous German fighter in operational service during late 1944, struggled to reach 30,000 feet and could barely maintain level flight at that altitude. The Focke-Wulf FW-190A performed somewhat better but still experienced significant power degradation above 25,000 feet. This high-altitude capability possessed profound tactical implications that German fighter commanders understood immediately. American bomber formations typically operated between 25,000 and 30,000 feet, where defensive fire from concentrated gun positions remained effective against attacking fighters, while German anti-aircraft artillery experienced reduced effectiveness due to longer projectile time of flight and decreased projectile velocity at extreme altitudes. German fighters attempting to intercept at these altitudes faced American escort fighters that maintained full combat capability, while German aircraft operated at the margins of their performance envelope. The Thunderbolts could accelerate, climb, and maneuver effectively, while German pilots struggled to maintain formation and execute attack maneuvers with engines producing perhaps 70% of rated power. Engine performance tests confirmed the remarkable reliability and robustness of the Pratt & Whitney R2-800 radial engine. The engine tolerated rough handling, sustained high power settings, and rapid throttle movements without the temperamental behavior that characterized some German engines, particularly late-war variants manufactured with substitute materials and inadequate quality control. The air-cooled radial configuration proved extremely resistant to battle damage compared to liquid-cooled inline engines, where a single hit piercing the cooling system could cause rapid engine failure. Formation flying exercises demonstrated the Thunderbolt's stability and ease of handling during the demanding task of maintaining precise position relative to other aircraft. The aircraft's inherent stability reduced pilot workload during long escort missions, where maintaining formation for hours tested pilot endurance and concentration. American bomber escort tactics required fighter pilots to weave continuously above bomber formations, maintaining higher speed than the bombers while remaining in protective position, a demanding profile that benefited enormously from stable, predictable handling characteristics. But the test flights that would prove most significant to German fighter tactics involved evaluating the Thunderbolt's diving performance, the characteristic that would ultimately define the aircraft's tactical effectiveness and challenge fundamental assumptions about fighter combat doctrine. Understanding the P-47D's capabilities in high-speed dives became the highest priority for Luftwaffe tactical planners who needed to develop countermeasures against American fighters that were increasingly dominating engagements through tactics that exploited specific performance advantages. The numbers alone proved sobering to German planners who understood the tactical implications of what test pilots were discovering. The P-47D could safely dive to speeds exceeding 550 miles per hour, substantially faster than any operational German fighter could achieve without encountering severe control problems or structural failure. The Messerschmitt Bf 109 experienced progressively worsening control stiffening above 450 miles per hour, with elevator forces becoming so heavy that pilots lacked sufficient physical strength to pull out of dives without trim adjustments that required precious seconds. The Focke-Wulf FW-190A suffered from dangerous tail flutter and control reversal phenomena at speeds exceeding 470 miles per hour that could prove catastrophic if pilots failed to reduce speed immediately. The Thunderbolt, by stark contrast, remained controllable throughout the entire high-speed dive envelope. Control forces increased predictably with speed, providing good feedback without becoming prohibitively heavy. The massive airframe with its robust construction remained stable without flutter, buffeting, or other dangerous characteristics. Most critically, pilots could initiate recovery from high-speed dives without excessive control force requirements, pulling smoothly back to level flight or climbing flight without fear of overstressing the structure or losing control. Hauptmann Voidisch described the experience in his post-flight report, with language that conveyed both professional admiration and tactical concern. The aircraft dives like a streamlined brick, accelerating rapidly to speeds where German fighters dare not follow. Recovery from the dive requires only moderate back pressure on the control column, entirely manageable without excessive physical effort or dangerous delay. The structural integrity throughout the maneuver never feels questionable, despite speeds that would terrify pilots in our own aircraft. This diving capability possessed profound tactical implications that German intelligence officers immediately recognized and documented for distribution to operational fighter units. American pilots flying Thunderbolts could employ tactics that were simply unavailable to German pilots in contemporary fighters. When engaged by German fighters at altitude, American pilots could push over into steep dives, accelerating rapidly to speeds where German aircraft could not follow without risking structural failure or loss of control. German pilots attempting pursuit found themselves forced to reduce speed or risk destroying their own aircraft, allowing the American fighters to escape at will. Even more concerning from a German defensive perspective, Thunderbolt pilots could attack from altitude, diving through German formations at speeds exceeding 500 miles per hour, firing concentrated bursts from 850 caliber machine guns, then extending away in continued high-speed dives that German fighters could not match. This hit-and-run tactic, which American pilots called boom and zoom, exploited the Thunderbolt's specific advantages while avoiding circumstances where German fighters retained superiority. Hans-Werner Lerch, who would become the most experienced Luftwaffe test pilot of captured Allied aircraft during the war, flew the captured Thunderbolt extensively during late 1944. His engineering background from technical university studies, combined with exceptional natural flying ability, developed through years of glider competition and powered aircraft experience, made him ideally suited for the demanding work of evaluating unfamiliar enemy aircraft without instruction manuals, qualified instructors, or standardized checkout procedures. Lerche approached captured aircraft with scientific curiosity rather than ideological prejudice, a professional attitude that made him invaluable to the Luftwaffe's technical intelligence programs. He would eventually fly more than 125 different aircraft types from multiple nations during the war without a single serious accident, a remarkable safety record that testified to both exceptional skill and careful methodology in approaching unfamiliar aircraft. When Lerche climbed into the Thunderbolt's cockpit for his first flight in the captured fighter, He had minimal preparation beyond studying the cockpit layout and instruments that German technicians had labeled with translated descriptions. He learned through direct experience and careful experimentation, making educated assumptions about systems operation and testing those assumptions cautiously at altitude where mistakes would not prove immediately fatal. The instrument panel reflected American design philosophy that favored standardization and logical arrangement. Critical flight instruments clustered in the center panel where pilots could scan them rapidly without excessive eye movement. Engine instruments grouped logically by system. Circuit breakers provided resettable electrical protection throughout the aircraft. The layout remained consistent with other American fighters, allowing pilots transitioning between aircraft types to adapt quickly without extensive retraining. But what impressed Lerche most profoundly was the aircraft's structural robustness and damage tolerance that became evident through examination of the airframe and discussions with German intelligence officers who had interviewed American prisoners. The P-47D absorbed punishment that would destroy equivalent German fighters, continuing to fly and fight after sustaining damage that seemed unsurvivable. Multiple redundant systems meant single failures rarely proved catastrophic to mission completion. Self-sealing fuel tanks prevented fires from small-caliber hits, technology the Germans understood theoretically, but had never implemented as comprehensively throughout an entire aircraft. Armor plate protected the pilot with particular attention to threats from behind and below where German fighters typically attacked. The massive radial engine could continue running despite losing multiple cylinders to battle damage, and the air-cooled design eliminated vulnerability to coolant system hits that doomed liquid-cooled engines. Lerche and other test pilots at Rechlin conducted numerous mock combat exercises to understand the Thunderbolt's tactical capabilities from both the American pilot's perspective and the German attacker's viewpoint. German fighter pilots would climb into Messerschmitt Bf-109Gs and Focke-Wulf FW-190As, then make simulated attack runs against the captured Thunderbolt while it performed various defensive maneuvers and tactical responses. Ground observers photographed the engagements from multiple angles. Combat cameramen filmed the exercises from chase planes, creating training footage that could be distributed to fighter squadrons across Germany and occupied territories. These exercises revealed uncomfortable truths that contradicted German assumptions about the relationship between aircraft weight and combat effectiveness. The massive Thunderbolt, despite weighing nearly twice as much as a Bf-109, proved extremely difficult to engage successfully when flown by a pilot who understood energy tactics and refused to fight on German terms. When German fighters attempted traditional dogfighting tactics, emphasizing tight turns and slow-speed maneuvering where the lighter Bf-109 held clear advantages, the Thunderbolt pilot would simply refuse engagement by accelerating away or diving to build speed. German pilots discovered they could not force combat on an unwilling Thunderbolt pilot who recognized an unfavorable tactical situation. The American fighter's superior speed at all altitudes and overwhelming advantage in high-speed diving performance meant skilled pilots could always disengage from unfavorable encounters, denying German pilots the sustained turning engagements where German fighters retained superiority. This tactical flexibility proved psychologically devastating to German pilots, who found themselves unable to bring their aircraft's advantages to bear against opponents who simply refused to fight under those conditions. Attacking from above using traditional German bounce tactics where fighters dove from superior altitude to build speed before attacking proved equally frustrating. The Thunderbolt pilot being attacked could simply push over into his own dive, accelerating rapidly to speeds where the attacking German fighter could not follow without risking structural failure. Even if the German pilot achieved a firing position during the initial diving attack, the brief engagement window measured in seconds before the Thunderbolt pulled away at speeds exceeding 500 miles per hour. The mock combat sessions demonstrated that the Thunderbolt's tactical doctrine represented a fundamentally different approach to fighter combat compared to traditional European thinking that emphasized dogfighting agility and/or sustained turn performance. American designers had deliberately created a fighter optimized for altitude performance, high-speed operations, and diving attacks while accepting lesser performance in slow-speed turning engagements. This represented sound tactical thinking that prioritized the missions American fighters actually flew, primarily bomber escort at high altitude and fighter sweeps against German airfields and transportation networks. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. German fighter pilots who observed or participated in these demonstrations came away deeply troubled by what they had witnessed. The comfortable assumption that German fighters remained superior to American designs in the characteristics that truly mattered for fighter combat dissolved when confronted with actual performance data and tactical exercises. German pilots recognized that they faced opponents whose aircraft possessed decisive advantages in the specific performance areas that mattered most for the high-altitude escort mission, particularly speed, altitude capability, and diving performance. The armament carried by the P-47D further impressed German evaluators who understood weapons systems. The fighter mounted 8 Browning Medvar 50 caliber machine guns, 4 in each wing, positioned outboard of the propeller arc. Each gun was capable of firing approximately 800 rounds per minute, creating combined firepower of approximately 6,400 rounds per minute, when all guns fired simultaneously. The typical ammunition load totaled approximately 3,400 rounds, distributed across all 8 gun positions, providing approximately 26 seconds of sustained fire before ammunition exhaustion. German intelligence analysts calculated the devastating effect of concentrated fire from 8 heavy machine guns converging on a target. The 50 caliber BMG cartridge delivered 3 times the kinetic energy of standard German 7.92mm rifle caliber rounds and comparable energy to German 13mm heavy machine gun ammunition. A single 50 caliber armor-piercing incendiary round could penetrate significant armor plate, destroy engine components, sever control cables, shatter canopy frames, and kill pilots from ranges exceeding 800 yards. When 8 such weapons converged fire on a target, even brief engagement lasting 1 or 2 seconds placed dozens of heavy projectiles into a small area with devastating effect. German pilots who had survived attacks by P-47D formations described the experience of being hit as catastrophic, with their aircraft often suffering immediate critical damage requiring emergency bailout. The concentrated firepower from multiple thunderbolts engaging a single target simultaneously made survival nearly impossible, even in the robust German fighters. The effectiveness of this armament arrangement was demonstrated during firing tests at Rechlin, where German technicians set up target arrays to measure penetration and destructive effect. 8 50 caliber machine guns, firing armor-piercing incendiary ammunition at typical combat ranges of 400 to 600 yards, could destroy or severely damage any German aircraft within seconds of achieving firing. Solution: the volume of fire and the kinetic energy delivered created destruction that exceeded what German pilots experienced from their own aircraft's mixed armament of machine guns and cannon. German fighters typically carried lighter armament consisting of machine guns and cannon in various combinations depending on specific variant and intended role. A Messerschmitt Bf 109G might carry one 30mm Mk, 108 cannon firing through the propeller hub, plus 2 13mm MG 131 machine guns mounted above the engine, supplemented occasionally by underwing 20mm cannon pods that severely degraded flight performance. Total ammunition capacity rarely exceeded 300 cannon rounds and approximately 600 machine gun rounds, providing perhaps 15 to 20 seconds of mixed fire before ammunition exhaustion. The Focke-Wulf FW-190A carried heavier armament with 420mm MG 151 cannon mounted in the wings, plus 2 13mm MG 131 machine guns in the cowling. This represented formidable firepower when hits were achieved, but total ammunition load still provided only brief engagement time before exhausting limited supplies. The German 30mm cannon proved devastating against heavy bombers when hits were achieved, but the slow rate of fire, limited ammunition, and significant ballistic drop at range made accurate shooting difficult, except at close range, where bomber defensive fire proved most effective. The Thunderbolt's 850 caliber machine guns represented a different philosophy that emphasized volume of fire over projectile size. The high rate of fire, large ammunition capacity, and flat trajectory of 50 caliber rounds made accurate shooting easier across a broader range of combat distances. American pilots could engage targets at longer ranges, where German cannon proved ineffective, then maintain fire throughout closing engagement until breaking away at minimum range. The sheer volume of projectiles increased hit probability substantially, making even average pilots effective in combat. Luftwaffe tactical intelligence compiled from Rechlin's testing program circulated throughout fighter units across Germany and occupied territories in the form of detailed technical bulletins, training films, and intelligence summaries. These documents provided operational pilots with accurate performance data, tactical recommendations, and explicit warnings about American fighter capabilities that differed substantially from earlier optimistic assessments and propaganda. The technical bulletin covering the P-47D acknowledged the aircraft's clear superiority in specific, critical performance categories, while attempting to identify areas where German fighters retained advantages that might be exploited through proper tactics. The document noted the Thunderbolt's exceptional high-altitude performance, enabled by the turbo supercharger installation that maintained full power above 30,000 feet, where German fighters experienced severe power loss. The analysis confirmed the American fighters' overwhelming advantage in diving performance, specifically warning that German pilots should never attempt to follow Thunderbolts into high-speed dives, where German aircraft encountered dangerous control problems and structural limitations. The bulletin emphasized the P-47D's superior speed at all altitudes, noting that German fighters could not catch fleeing Thunderbolts through sustained pursuit. The document acknowledged the devastating concentrated firepower from 850 caliber machine guns that could destroy German aircraft within seconds. The structural robustness and damage tolerance that allowed Thunderbolts to survive hits that would doom German fighters received specific mention as a significant tactical consideration. However, the tactical bulletin also identified areas where German fighters retained exploitable advantages, attempting to provide operational pilots with some basis for tactical confidence, despite the sobering overall assessment. The Messerschmitt Bf 109 maintained superior sustained turn performance at medium altitudes between 10,000 and 20,000 feet, offering advantages in turning engagements, if German pilots could force such combat. The Focke-Wulf FW-190 possessed exceptional roll rate that exceeded the Thunderbolt's performance, allowing rapid direction changes during high-speed maneuvering. German fighters generally exhibited better initial climb performance from sea level to approximately 15,000 feet, though this advantage disappeared at higher altitudes where the turbo supercharger provided the Thunderbolt with overwhelming superiority. The tactical guidance emphasized avoiding high-altitude engagements where possible, attempting to draw American fighters down to medium altitudes, where German performance remained more competitive, exploiting superior turn performance through forcing sustained turning engagements, and never attempting to dive away from attacking Thunderbolts as escape tactic. These tactical recommendations reflected German recognition that their fighters now operated at systematic disadvantage against American escort fighters in the high-altitude environment where bomber escort combat actually occurred. The suggestions for exploiting German advantages required American pilots to make tactical errors by accepting combat on German terms, an increasingly unlikely scenario as American pilot training emphasized energy tactics and avoiding circumstances where enemy fighters held advantages. But understanding enemy capabilities and developing countermeasures provided limited practical benefit when the fundamental performance disparities remained unbridgeable through available means. German pilots received excellent tactical intelligence about P-47 capabilities through the Rechlin testing program, yet this knowledge could not eliminate the performance advantages American fighters possessed or create capabilities German aircraft lacked. The captured Thunderbolt underwent additional specialized testing throughout November and December 1944, as German engineers attempted to understand every aspect of the design that contributed to the aircraft's impressive performance. The turbo supercharger installation received particularly intensive study as German engineers recognized this technology as the primary factor enabling the P-47D's exceptional high-altitude capabilities. The system consisted of a turbine driven by hot exhaust gases that spun a centrifugal compressor forcing compressed air into the engine intake. An intercooler positioned in the wing roots cooled the compressed air before it entered the engine, increasing air density and allowing more fuel to be burned efficiently. Complex ducting routed exhaust gases from the engine to the turbine in the rear fuselage, then exhausted spent gases through wastegates that could be adjusted to control boost pressure. The entire installation added significant weight and complexity compared to mechanically driven superchargers, but recovered waste exhaust energy that would otherwise contribute nothing to aircraft performance. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.